So, new technologies aiding capture. New technologies is often followed by new knowledge is often followed by new technologies, or vice versa.
By the way, Mike. Thanks for doing my presentation. we should have prepared notes before.
So, Tom Rossiter, at my right side, is head of precision fishing in safety net technologies in England. The floor is yours.
Thank you very much. Good afternoon, everybody, and thank you, Mike, as I say, for giving my presentation. My videos are substandard, but hey ho, we'll give it a go. Right, good afternoon, everybody. As I say, my name's Tom Rossiter. I've got 15 minutes to talk to you about new technologies, aid and capture. So it's a peak, because I could probably talk to you for 15 hours if the truth be told around this whole area. I'm going to start with the conclusion, and the conclusion is, well, catch welfare starts as soon as the fish comes in contact with your operation. So it doesn't matter what gear you're working or anything else, that's when the process starts. So I'm just going to very, very quickly run through a number of kind of different areas that are advancing technology-wise that affect catch welfare and overall catching ability in the fishing industry. So first up, we've got fish handling. I'm glad to say we don't see so much of this anymore, but this was very much the way in the past, where the fish was dumped on the deck in pounds, and it was scooped up with shovels, with your hands, with whatever you could get a hold of. And the animals, yeah, they didn't have a very good end of life experience, shall we say. Vessel design, absolutely moving forward at a rate of knots. There's a number of motivations for this. But in the example you see on the screen here in front of you, this is a stern ramp on a Nephrops trawler out of Scotland. It's speeding up the process of getting the fish on board. There's less bumping of the cod end as it comes on. It slides up the ramp. It's a very smooth process. And as a result, the vessel's got better quality animals coming into the vessel. Gear monitoring technology has been around for a long time. It is developing all the time, and there's new systems coming onto the market. It's not just your trawl doors. Mike mentioned about sensors on your cod end to see exactly how much fish you've got in the cod end and to know when to haul. There's also sounding equipment, other different types of tilt sensors, etc. So this is an area of innovation, and there's some big companies doing some really interesting stuff in this area. Probably one of the biggest is ground discrimination and understanding where you're fishing. You know, fishermen in the past tended to go from A to B and you go in a straight line, but the seabed doesn't work like that. And if you look at the roads, we tend to go up a hill and you don't go straight over the top of it. And there's a reason for it, but because you can't see it, it's difficult to understand. But the technology we have now in terms of ground discrimination makes areas a lot more accessible, and keeps the gear where it's appropriate, as opposed to putting it in places maybe where it's less so. Satellite data. Satellites in the sky, we're all kind of familiar with them. Well, they actually collect some useful marine data that can be used in the fishing process, and has been for a number of years. Like the tuna industry have used satellite data now for probably 30 years to help them with identifying where the optimum places to fish are. Shared data. Fishermen working together in a collaborative manner. This is fairly new and fairly radical to fishermen, because your individual enterprises, it's not really in your interest to collaborate and cooperate, but there's significant benefits to be had from that. Here's an example from a system, BatMap. It's used in Scotland to identify areas where there's high levels of risk of bycatch. So the fishermen are basically trying to help each other to avoid the bycatch, and that's done through technology. And okay, they're not the boat, but you know, fishermen and scientists, we're getting better at our jobs, and that kind of drives the, I suppose, the advancements as well. So it's not just about the vessel itself, right? This is a video. I'm going to talk over the video, but this basically, I think there's going to be some text in there as well. It's a sonar technology. It's a Bruno system. It could be, you know, Simrad. It could be anybody else's. But this is kind of where we're at. Right, I'm going to give a little anecdote. A couple of weeks ago, I was very fortunate. I went to Greece. My expectations when I was going to Greece were crusty old fishermen on the harbour, mending nets, fish the size of your little finger, not very good. And I was in for a bit of a shock. I had the pleasure of going out on a sardine per se net vessel, and it's probably the most precise fishing I have ever experienced in my life. So these guys, they had 5 fads. They'd set the fads in the water. They're temporary fads, and on each of the fad they've got a sounder, and they also had a light. And the idea is the light attracts the feed fish, which the sardines are attracted to, and then you get aggregations or shoaling effect. So you got 5 of those already in the wheelhouse. Then there was 2 other sounders on the boat. In addition, they had 2 sonars, one long range, one short range. And what they were looking to do was identify which shoal, which bunch of fish were the ones they needed to catch. So what did they need to catch? Well, the market size was between 15 and 20 centimeters optimum. That's what you get your best price for. So that's what they were targeting. But in addition to all that equipment, they also had a brand new system, and I'd never seen it before, come across it before, and it blew my mind. And they had a sounder system that was actually able to measure the water flow under the vessel. And what you get is you get kind of different strata as such of the water. So let's say you're in 50 fathom of water. The first 10 is tides flooding east. Okay, got that. But underneath that there's another river, and underneath that there's another river, and underneath that's another river. So as these guys are shooting the CNET, if they got that wrong, they'd end up actually circling the wrong shoal of fish, and it's a disaster. And they're targeting anything between half a ton and 3 ton. Any more than 3 ton, not interested. And this was like absolutely mind-blowing. But the best bit was they had a guy in a rowing boat that was out in the middle. So they shoot around one of the fads, and there was a guy in a rowing boat. His job was to keep the fad in the middle of the net. And it could be quite windy and it'd be tough work and everything else, but he was rowing to keep it in the middle. And the idea was he was trying to maintain the fish in the center of the net to minimize the any kind of impact from the gear itself. So that kind of stress at the end was at the end, not in the middle. And as a result, I got on the vehicle through to the fish market, and we got mobbed when we got to the fish market because the folk knew what boat this fish was coming off of. And there was literally guys opening the back doors in this lorry to get at his fish, to have it in their restaurants or shops or whatever next day. So that was absolutely fascinating experience. And that's how technology can be used. Right. So what about the gears? Well, Mike's kind of spoiled me thunder here, but anyhow, I'll carry on. So you say. So there's a lot of work going into this, and has been for many, many years. 2 examples here, catching. We've got the Proficient Seafood Harvest, and Martin's going to be up shortly and talking about that. But systems to kind of radically change how we do it, catch better quality, and having less impact. A Norwegian system, the Ava Ocean, that are collecting scallops for the first time up north and getting a lot of success. It's very secret. It's hard to get a whole lot of information online, but it's successful, and it's a Norwegian system. And that's a recurring theme here. Steerable trawl doors. You know, this is technology where you can steer your net in the water rather than having to steer it by what's going on the boat. It steers itself. And I was speaking to Tuberon at the weekend, and they're now looking at bringing out a system for demersal trawls as well as pelagics. So this area is moving fast. The humble crab pot. Here's another Norwegian invention to catch and improve the efficiency of crab potting. There's a British company called FishTech. They've invented two systems, the shark guard and the hook pod, around avoiding incidental bycatch. Okay, thank you. Lights, something I've spent a lot of time and effort on myself. Artificial baits and lures. It's a technology that's certainly coming into our industry. Smart trawl, it's a Scottish system. Game of trawls, that's done through, God, I can't even remember now. There's a large project on it, and then deep vision systems as well. Identifying what's in your net and picking the ones you want to keep. And as Mike was suggesting, releasing the ones we don't want to catch on the seabed. Sensor technology, understanding the environment. We definitely have a long way to go there. Ghost fishing, there's technology out there to help us avoid that, and Mike's touched on quite a bit of that as well. And my own area is underwater cameras, so I'm going to, in my last 4 probably minutes, quickly run through a few videos to kind of talk about what we've been doing, what we've learned in the period. Okay, so the first one here is similar to Mike's, looking at fish behavior as it comes in over the ground gear. So this is on a demersal trawl in Scotland. And what we're seeing here are haddocks and whitings coming in. And then, to follow on with Mike's comments, the behavior remains, the behavior has changed by the environment, but it's consistent. You can't just scare them away. The scaring effect is there from the trawl. You can't really augment that and make it any more or attenuate it, unless you do something like this and introduce a seal. So these are squid in a net. You'll see them normally there. And next thing, seal turns up. The ink is coming from the animals because they're stressed. They're trying to avoid the interaction with the squid. But then as the seal's gone away, they're back into position. So it takes a really, really significant thing to break out from normal behavior. Okay, so 2 more videos here. So the first one is of a square mesh panel in a net. We see fish going past. Some are swimming out, but the vast majority of them actually are going back. And it's more around water flow rather than, I can see a hole, I'm getting out of here. Fish don't understand that they're in danger as such. They will behave how they normally behave. The second video, we can see fish in the cod end swimming around. There's a flatfish just come up. But the water flow in the cod end is significantly reduced. So we can start looking at using that to try and help the animals to escape, because that's the point where the penny drops to go, I'm in trouble. I need to do something about it. Okay, here's 2 videos. Exactly the same place on the net. The video on the left shows fish inside the net and not escaping, and the video on the right shows fish inside the net and escaping. Well, what's the difference? The difference is the sediment type. The one on the left is a mud sediment, which is fluidized as you travel over it, and that then the fish have to breathe that across the gills. It makes them sick, and they can't compete and they can't get out. The second one's on a sandy sediment, and totally different world. So we've learned this just by studying what they're, putting a camera down there and seeing what's going on. Okay, can we use that to help with fish welfare? Absolutely, yes, we can. And we are doing some work at the moment in terms of like sediment suppression sheets, etc. Okay, next one is here. We've got 2. Here's a system we deployed in the summer. It's on a Nephrops vessel where the fisherman doesn't want any fish in his net. He just wants to catch the prawns or the Nephrops. And we're seeing fish swimming out. The one on the left, high turbidity, but we're seeing lots of fish coming out. The one on the right was at the point where we were hauled back and we saw a flat fish swim out. It doesn't matter what size square mesh or diamond mesh you have, big flat fish, you're going to keep it. Okay, so we're learning how to help these animals escape at a point where they have a better chance of survival. So iterating quickly, since then we've done extra work, and what we have here is a video of the next version of it, the escape system, which is a tunnel. You can see a chain holding it down, and then the one on the right is a camera on the outside. Now, what's really interesting here is you can see the big hole there, and you see the fish swimming out of it. But as they come out, the way we've rigged it, we've opened some of the diamond mesh just before it, and nearly half the fish swam out the diamond mesh. So you've got this massive hole where you're going to get out no bother at all, or you've got this tiny little hole that you're probably going to have to squeeze through, and the fish go, well, I'm going for the first hole I see. So we've got to understand the mentality of the fish and think like a fish to some extent. Okay, I've got 4 on here. Mike kind of showing you some of the behavior in terms of flatfish. We've seen the trawl door before. Here's the trawl door getting shot. The one bottom left here is just fixing some gear issues, using the cameras to fish more efficiently. Because there's no point in putting your gear in the water and not catching anything. You're going to spend longer out there. It's inefficient. And the last one down the bottom right-hand corner is from a scallop fishery in the US, where we went back over a tow from the previous day, and we were able to see the lines that were made from the previous tow. And basically, we need to understand what impact we're having, but we shouldn't just judge a book by its cover by looking at a piece of gear on the deck and going, oh, that's going to destroy everything. Actually, the reality when it's down in the sea and on the seabed is it's actually incredibly light and incredibly precise as well. And what do I mean by precise? Well, if a fisherman's net isn't working right, he may take one mesh out of maybe 300 meshes, and that one mesh will be the difference between the gear working correctly or not working correctly. So, in terms of precision fishing is a lot more precise than what we understand it to be. And yeah, we need to understand it, and we need to share that knowledge as well amongst ourselves and out to the wider community. So that's pretty much it from me. The trawl door will fall over shortly, and that'll finish me off. Thank you very much.